Alright guys, second video. We're going to do a whole bunch of problems, and obviously these problems are already posted in the notes for chapter 3. I think it's chapter 3.5 part 2 if I remember right. Okay, so you have access to them just like the last video. Okay, so we're going to do a whole bunch of similar problems we did on the last video just to make sure everybody's on the same boat. Okay, so this first guy, we got to use the product rule, and then within the product rule we have to use the chain rule. Okay, so if I go f prime of x, I got to apply the product rule. The first times derivative of the second plus the second times derivative of the first. So it'd be 3x minus 7 squared times the derivative, okay, of 2x plus 5 squared plus the second 2x plus 5 squared times the derivative of the first 3x minus 7 squared. Okay, so right here you have to use u substitution, and so your u would end up being 2x plus 5, so your du dx ends up being just 2. And then over here we have to do the same thing. Okay, so your u is 3x minus 7, so your du dx is just 3. Okay, so let's see. All right, bring this guy down. Okay, so I've got 3x minus 7 squared. Okay, so let's see. If this is u, that'd be like u squared. So the derivative of u squared would be 2u times the derivative of u. So I get 2 times u, which is 2x plus 5, times the derivative of u, which is just 2. Okay, plus, bring the 2x plus 5 squared down. 2x plus 5 squared, like that. And let's see, when I take the derivative here, okay, that 3x minus 7 is your u, so I'm taking the derivative of u squared. So I'd get 2 times u, which is 3x minus 7, times the derivative of u, which is 3. Okay, so now from here on out, it's just a matter of just cleaning things up. Okay, so let's do that. Okay, so let's see, right here, I would get 4 times 3x minus 7 squared times 2x plus 5. Okay, and let's see here, I'm going to get a 6 times 2x plus 5 squared times the 3x minus 7. All right, now clearly that's one form of the answer. I just don't think it's a very good form. Okay, so what am I going to do here? I'm going to start looking for GCFs. And if I treat this as one term and this as one term. Okay, so let's see. With the 4 and 6, I can factor out a 2. Okay, notice that I have 3x minus 7 squared and 3x minus 7, so I can factor out one factor of 3x minus 7. And then with the 2x plus 5 and the 2x plus 5 squared, I can factor out one factor of 2x plus 5. Okay, so let's see, what am I left with? Well, if I take all of this GCF away from this, okay, I'm left with a factor of 2. I'm left with a factor of 3x minus 7. And let's see, the 2x plus 5 is taken away. So what am I left with here? Well, if I factor out a 2, I'm left with a factor of 3. I took one factor of 3x minus 7, so that guy's gone. And I took one factor of 2x plus 5, so I took one away, I'm left with 1. Okay, 2x plus 5. Okay, so all I got to do is just simplify inside here, okay, and collect similar terms, obviously, and then just check again, do I have another GCF? So right here, I'd get 6x minus 14 plus, let's see, that would be 6x plus 15 right there. And so I just collect similar terms, bring my GCF down, 3x minus 7, 2x plus 5, and then I collect similar terms, and I'm going to get a 12x plus 1. And so I take a look here, do I have a GCF I can pull out? And the answer is no, because the GCF is 1, so it doesn't do anything. Okay, so that to me is the best form of the answer. Now, if you want to keep going, if you want to expand this, that's up to you. I just wouldn't advise it, but clearly you could do that. Okay, so we got that first guy down. Okay, now we got to do the second guy. Okay, so let's see. Could we take the derivative the way it is right now? Absolutely. Wouldn't need the chain rule then. Okay, so we could go the first times derivative of the second plus the second times derivative of the first. So we could do that, okay, and come up with an answer, and it would be a viable answer. But both of these guys might be perfect square trinomials. And so I might be able to take this guy and rewrite it so it looks like the first one. So I'm going to take a look at that and see if I can do that. All right, so let's see. This first guy, if it's a perfect square trinomial, okay, the square root of 9x squared is 3x. Bring the plus down. Square root of 16 is 4. And so let's see, this middle term would have to be 2 times 3x times 4, which is 24x. So that works. Okay.
Good morning, staff. We will not have a BLT meeting today. If anyone has any individual questions in regard to the emails yesterday, please feel free to stop up and see me in the office at any time. Thank you.
Sorry about that, guys. Okay, so let's see. If this one works out, square root of 25x squared is 5x. Bring the minus down. And then the square root of 1 is 1. So let's see. This middle term would have to be 2 times 5x times 1, which it is. Okay, so both of these guys are perfect square trinomials. So I can attack this problem just like I attacked the last one. So we go f prime of x, and it's going to be the first times derivative of the second. So it'd be 3x plus 4 squared times the derivative, okay, of this guy, 5x minus 1 squared, plus this guy, 5x minus 1 squared times the derivative of the first guy right here, okay, 3x plus 4 squared. Okay, so here's where we have to use the chain rule. Okay, so right here, if I let u be 5x minus 1, then my du dx is obviously just 5. And I have to use the chain rule here. So if I let u be 3x plus 4, then my du dx is just 3. Okay, so let's see. Bring this guy down. 3x plus 4 squared. Okay, so this would be like the derivative of u squared. So I'd get 2u times the derivative of u. So 2u would be 2 times 5x minus 1 times the derivative of u, which is just 5. Okay, bring this guy down. So I've got 5x minus 1 squared. Okay, so this is taking this derivative, it's going to be like the derivative of u squared. So it'd be 2u times the derivative of u. So it'd be 2 times u, which is 3x plus 4, times the derivative of u, which is 3. Okay, so from here on out, it's just a matter of cleaning things up. So let's see, I've got a 2 times 5, so that's my 10. Bring this guy down, 3x plus 4 squared. Bring this guy down, my 5x minus 1. Okay, here I have the 2 times 3, so that's a 6. Okay, bring this guy down, 5x minus 1 squared, and then bring this guy down to 3x plus 4. So again, if I treat this like a binomial, right here, and I look for a GCF. So let's see, I can factor out a 2 from the 10 and the 6. All right, 3x plus 4 squared and 3x plus 4, so I can factor out one factor of 3x plus 4. Okay, I've got 5x minus 1 and 5x minus 1 squared, so I can factor out one factor of 5x minus 1. All right, and then let's see what I'm left with. Okay, so I started with a 10, I factored out a 2, so I still have a factor of 5. Okay, I started with 2 factors of 3x plus 4, and I pulled 1 away, so I still have 1 left, 3x plus 4. Okay, I pulled away one factor of 5x minus 1, so no more 5x minus 1's there. Bring the plus down. Let's see, 6, I pulled out a factor of 2, so I'm left with a factor of 3. Here I pulled out a 3x plus 4, so I have none left. Here I pulled one factor of 5x minus 1 away, so I'm left with one factor of 5x minus 1. Okay, so now it's just a matter of just cleaning this up. Okay, so let's see if I distribute, I get 15x plus 20 plus 15x minus 3. Okay, and so I'm going to collect those similar terms. So I get 2 times the 3x plus 4 times the 5x minus 1. And then I collect similar terms and I get a 30x plus 17. And then the last thing I'd look for is, do I have another GCF that I can pull out? Well, the GCF here is 1, so it doesn't do anything. So I am finished. Okay, and once again, that's a perfectly acceptable form of the answer. If you want to expand it, that's up to you. I just don't think it's a good idea. Okay, so that guy's done. Okay, so let's see what we got going on here. Okay, again, we could just go ahead and let u be this guy if we wanted to. Okay, and rewrite this as f of u is u to the negative second and take the derivative, but this guy might be a perfect square trinomial. Okay, so it might be able to help me out if I can factor that guy. So let's see what's going on. If I can, it'll be the square of a binomial to the negative second, like that. So let's see, if this is a perfect square trinomial, what has to happen? The square root of 4x squared would be 2x, and the square root of 9 would be 3. Okay, and boy, did we do this problem already? I think we did it on the last sheet. I'm going to do it anyway. I'm just going to do it again. Okay, so let's see what's happening. Okay, so if I square 2x, I get 4x squared. If I square 3, I get 9. If I go 2 times 2x times 3, I do get 12x, so it works. Okay, so this guy, using my power of a power rule, I get 2x plus 3 to the negative fourth. Okay, so if I let u be 2x plus 3, then my du dx ends up being 2. Okay, so I go f of u, okay, this would be u to the negative fourth. So my f prime of u is negative 4u to the negative fifth times du dx. And then we just go back and substitute. So I get f prime of x equals negative 4 times u, which is 2x plus 3, to the negative fifth times du dx, which is 2. Okay, and then we get rid of negative exponents because we don't like those. Okay, so that 2x minus 3 to the negative fifth goes down below, becomes 2x plus 3 to the positive fifth, and then the negative 4 times 2 is negative 8 on top, and we're done. And there's your answer. And I think we did that on the last video. Not sure. If we did, we did. Okay, no big deal. Okay, so let's see. All right, so we got some problems where we are dealing with trig functions. Okay, so let's get these first two done with the sign. Okay, so let's see. With this guy right here, if I let u be negative 6x, then my du dx ends up being negative 6. Okay, so I go ahead and substitute my u in, so my f of x becomes f of u, and my sine of negative 6x just becomes sine of u. Okay, so my f prime of u, and remember, coming back, make sure you have this guy handy if you need it. Okay, so the derivative of the sine is a cosine, so I get cosine of u times du dx. And then we go ahead and substitute back in, so f prime of u becomes f prime of x. Okay, and we get the cosine of u, which is negative 6x, times the derivative of u, which is negative 6. And then we just clean it up. So I get negative 6 cosine of negative 6x. Okay, and I'm done with that guy, so that guy's done. Okay, let's get the next guy here. Okay, again, another sine. So if I let u be the 3x plus 5, then my du dx ends up being just 3. Okay, so if I do my u substitution, my f of x becomes f of u, and so the sine of 3x plus 5 just becomes the sine of u, and so I take my derivative, f prime of u, ends up being cosine of u times du dx. And then we go ahead and substitute, so we go back to f prime of x. So I get the cosine of u, which is 3x plus 5, times the derivative of u, which is 3, and then we just clean it up. So I get 3 cosine of 3x plus 5. And we're good. Okay, so that guy's out of the way. Okay, let's do a couple of cosines here. All right, let's see. Okay. All right, so let's see. If I let u be 1/5 x, then my du dx ends up being 1/5. Okay, so we're good there. Okay, so I have, doing my u substitution, f of x becomes f of u. So cosine of 1/5 x becomes cosine of u. And then I take my derivative, f prime of u would be the opposite of the sine of u times du dx. And then we go ahead and substitute, so f prime of x equals the opposite of the sine, well, u becomes 1/5 x, 1/5 x, times the derivative, okay, of u, which is 1/5. Okay, so we could rewrite this as negative 1/5 sine of 1/5 x. That's one way to do it. Or I could write it as the opposite of the sine of 1/5 x all over 5. Either way, okay, I kind of like this better because I don't like that fraction, you know, in that numerator there. And I know it's technically it's not a complex fraction, but for some reason I just like this guy better. But that is perfectly acceptable, just a matter of what you want to do there. Okay, so let's see, that guy's down. All right, let's do this guy. Okay, so let's see, if I let my u be 64 minus x cubed, then my du dx ends up being negative 3x squared. Okay, all right, so f of x becomes f of u, and so cosine of 64 minus x cubed becomes cosine of u. Okay, so f prime of u gives me the opposite of the sine of u times du dx. And then we just go ahead and substitute, so f prime of x equals the opposite of the sine of u, which is 64 minus x cubed, 64 minus x cubed, times the derivative of u, which is negative 3x squared. And then we just clean up. So let's see, negative times negative is a positive, so I get 3x squared times the sine of 64 minus x cubed, and we're done. Okay, we're in good shape there. Okay, I don't see any reason to mess around with that. Don't necessarily know if there's anything you could do. Looks good to me. Okay, all right, so we've done a number of problems with sine and cosine, so we have to start looking at some problems where we're dealing with other trig functions, but it's the same thing. Okay, so let's see, this guy, we got a couple of secants here, don't we? You know, we got a secant and a cosecant. Okay, so let's see, if I let u equal 81 minus x squared. Then my du dx ends up being negative 2x. Okay, so I use my u substitution, so f of x becomes f of u, and let's see, that just becomes the secant of u. Okay, so f prime of u equals, again, if you don't remember that off the top of your head, you go here, through the secant is secant times tangent. Okay, so I get secant of u, tangent of u, times the derivative of u, like that. And then we just go back and substitute. Okay, so I get f prime of x equals the secant of 81 minus x squared times the tangent of 81 minus x squared times the derivative of u, which is negative 2x. And then we just clean it up. Okay, so put the negative 2x out front, negative 2x secant of 81 minus x squared tangent of 81 minus x squared. And once again, we got what we need here, so we're in good shape. I don't see anything to do to mess around with that. Okay, so that should take care of that guy. Okay, got one last one to do. Okay, cosecant. All right, so let's see. Let's get rid of this. This one looks a little bit better. Sorry, guys. All right, so if I let u equal 12x cubed, then my du dx ends up being 36x squared. Okay, so do your u substitution, so f of x becomes f of u, and this becomes cosecant of u, and so we take our f prime of u, and once again, cosecant, you go back here, okay, the derivative of cosecant is opposite of cosecant, cotangent. Okay, so I get the opposite of cosecant of u, cotangent of u, times the derivative of u, right there. And then we go ahead and substitute. Okay, so f prime of u goes back to f prime of x, and that's what we're looking for. So we get the opposite of the cosecant of u, which is 12x cubed, times the cotangent of u, which is 12x cubed, times the derivative of u, which is 36x squared, and then just clean it up. So I get negative 36x squared cosecant of 12x cubed times the cotangent of 12x cubed, and we are done. And once again, okay, I don't see anything else you could possibly do to clean that up. Okay, so we're in good shape. Okay, hopefully this helps you guys out.